Ladies and gentlemen, I am Yi-Ming Huang. Today my presentation title is Design and Implementation of Distributed Image Recognition App with Federal Learning Techniques. Next, I will present my research work. This is my presentation outline. Contents: Part 1, Motivation. Part 2, Introduction to Federated Learning. Part 3, System Architecture. Part 4, System Implementation. Part 1, Motivation. In recent years, machine learning has become very popular, and everything such as face recognition, medical detection, and even driverless driving has entered people's life. Although it can bring us great convenience, but in traditional machine learning, the problem of network bandwidth and network delay cause poor real-time and privacy problem. In order to solve the above problems, the emergence of federated learning has been promoted. Part 2, Introduction to Federated Learning. Federated learning is a decentralized machine learning architecture proposed by Google in 2016. There is a central server with multiple nodes participating in the training from scattered locations. The equipment first trains with its data and then uploads the respective model weights to the central server after the training, and then the central aggregates these weights. The most common form is the server client, from which relies on each node. Client to compare its model parameters to optimize all models simultaneously, so even if the data cannot be shared, it can be learned, which can take into account privacy issues and models. The problem of prejudice. Part 3, System Architecture. This system is mainly divided into two parts. The first part is the server side, and the second part is the client side. First of all, on the server side, this system uses Kotlin as the main programming language. Client side, which is mainly built in the Android operating system and uses Kotlin as the main app programming language, and Deep Learning 4J as the machine learning framework. Training and image recognition will be performed on the device itself. The first step, the server generates an initialized global model in the initial stage, and then transmits the global model to each connected client. In the second step, the client receives the initialized global model. The third step is to train this model and upload the updated model parameters to the server. The fourth step, after receiving the weights obtained after client training, aggregate the weights obtained by each client to generate an updated model. The fifth step is to transfer the updated model to the client. We use the Cyphertent data set as our data set. Part 4, System Implementation. Server System Design and Implementation. These are the functions of server. Initialize the model. Receive the weight returned by the silent. Train the collected weights. Server UI interface to view the training process and results. Our system supports multiple clients. Multiple clients can be executed and send back the weights to the server at the same time. At average algorithm. Client image classified app. This is the homepage of the application. We use an original camera of the phone to take a photo. This is the first identification screen. This is our training model. The application will use the CNN model for training. This is training information and process screen. It will display model parameters and training process. This screen is identification after training. The accuracy rate of the airplane increased from 0.32 to 1. Adjustment of model parameters. This is the first identification. The accuracy rate of the airplane is 0.33. The accuracy rate of the ship is 0.34. The identification result is a ship. This is the identification result after 50 epoch training. The accuracy rate of the airplane is 0.96. The accuracy rate of the ship is 0.02. The identification result is the airplane. This is the identification result after 100 epoch training. The accuracy rate of the airplane is 0.99. The accuracy rate of the ship is 0. The identification result is an airplane. Parameter setting. In our test, although the 200 epoch accuracy rate is the highest, it is very easy to crash due to time-consuming and excessive consumption of mobile phone performance. In terms of accuracy, time, and performance, the final decision was made to set epoch 100 times.